Today, we're going to pull back the curtain on all those apps and websites you use every single day. We're talking about their hidden structure, the very blueprint that makes them work. It's called application architecture.
I mean, really think about it for a second. You tap an icon on your phone and boom, you're streaming a movie, ordering dinner, or video chatting with someone halfway across the globe. How does that incredibly complex dance of data actually happen so fast? Well, the secret, it's all in the architecture.
Okay, so what exactly is application architecture? At its core, it's the master plan. You wouldn't build a skyscraper without a detailed blueprint, right? That plan tells you what materials to use, how the floors connect, where the plumbing and electrical systems go. It's the exact same idea in the digital world. This is the blueprint that lays out the technologies, the structure, and how every single piece is going to communicate with every other piece.
So, to get our heads around all this, here's our plan. We'll start with what this blueprint actually defines. Then we'll dig into the huge fundamental choice between centralized and distributed systems. That'll lead us right into the revolutionary client-server model. From there, we'll see how that idea basically powers the internet today, and we'll wrap up with some other key choices that architects have to make.
Right, so what actually goes into this master plan? It's really about making a whole series of absolutely crucial decisions at the very beginning. Decisions that are going to shape the entire system for its whole life.
The architect has to decide the big stuff first. Is everything going to run on one giant computer, or will it be spread out across a network? They have to figure out how to store and distribute all the data, what programming languages and tools to use, how to plug in software you buy off the shelf, and of course, what the user will actually see and interact with. Trust me, every single one of these choices has massive implications for performance, cost, and security down the line.
And that brings us to the first and maybe the most fundamental fork in the road for any system designer. Do you put all your power in one central place, or do you distribute it? This one choice basically defines two completely different eras of computing.
So, back in the day, everything was about centralized systems. Just picture a massive mainframe computer humming away in a basement somewhere. Users would connect to it using what were called dumb terminals, basically just a screen and a keyboard with zero processing power. All the real work, all the thinking, happened on that one single host machine. Now, in a distributed system, which is what we use for pretty much everything today, all the components and the workload are spread out across tons of different computers that are all connected by a network.
So, why the big shift? Why did we move away from that centralized model? Well, it's because the world itself became more distributed. Businesses started to decentralize, and they needed to move their information and services closer to where their users actually were. Distributed computing let them tap into the power of all those brand new personal computers that were popping up on every desk. This led to way more user-friendly interfaces, and, at least at first, it was a lot cheaper than buying one single monolithic mainframe.
This huge shift led to the dominant idea of the last few decades, what we call the client-server model. This was the brilliant solution for organizing and managing these new distributed systems in a way that actually made sense.
Now, to really get the client-server model, you have to see a system as being made of 5 distinct layers. Let's use ordering a pizza online as an example. The presentation layer, that's the menu you see on the website. The presentation logic is what stops you from, say, ordering a negative number of pizzas. The application logic, that's the core business rule that calculates your total cost. The data manipulation layer is what actually saves your order into the database. And the data is, well, it's the record of your pizza order itself. The real magic of architecture is deciding where each of these layers is going to live.
The very first attempt at this was the file server model. Here, the data lived on a server, yeah, but almost everything else, all the logic, happened on the user's PC. This meant your computer had to be a real powerhouse, a fat client, because it was doing all the heavy lifting. And the problem? Oh, it was a big one. If the client needed just one piece of information, it often had to pull the entire database file across the network. It was a total traffic jam.
The next step in the evolution was the two-tier model. And this was so much smarter. The client doesn't ask for the whole library anymore. It sends a very specific request, like, hey, just give me this one customer's record. The server, now a proper database server, does all the work of finding that specific data and sends only the result back. This move drastically, and I mean drastically, cut down on network traffic and made everything way more efficient.
And that brings us to what we consider the modern standard, the 3-tier or N-tier model. The key innovation here is one word: specialization. We take that application logic, all the business rules, and we put it on its own dedicated application server.
So now, the client just handles the presentation, the application server handles the rules, and the database server handles the data. This separation of powers is exactly why an app like Uber or Netflix can handle millions of users at once. It gives them incredible flexibility and the ability to scale up.
So this three-tier model, it's the foundation for the biggest distributed system of them all, the Internet. Yep, the entire web is built on these client/server principles, just blown up to a massive global scale.
When you open a website, your web browser is acting as what we call a thin client. Its main job is just presentation, showing you the web page. It sends a request out to a web server, which might then have to talk to an application server to process your request, which in turn might need to pull information from a database server. You see, it's a perfect, real-world example of that N-tier architecture at work.
This model also really helps us see how all those different technologies you hear about actually fit together. HTML, that's the language that builds the presentation layer, what you actually see in your browser. A server-side language like Java or Python is often handling the application logic. And SQL is pretty much the universal language that everyone uses to talk to the database. Each piece of tech has its own specialized job within the overall architecture. Of course, building a massive system involves a lot more than just picking a client/server model. An architect has a whole toolbox full of other crucial design choices to make, especially when it comes to data and communication.
A huge decision is how to distribute the data. You could just keep it all in one place, sure. Or you could partition it, maybe putting customer data for Europe on a server in Germany and data for Asia on a server in Singapore. You can even replicate data, which means making copies in multiple locations. This can make things faster for users or act as a backup in case one of the servers goes down.
But wait, with all these separate, distributed pieces, a critical question comes up. How do they all talk to each other, especially if they were built with different technologies? The answer is this amazing stuff called middleware. You should think of it as the essential glue or maybe the universal translator of the software world. It's the software that sits in the middle and allows all these different programs on all these different computers to communicate seamlessly. It's the real unsung hero that makes our complex digital world possible.
So from those old centralized mainframes to the globally distributed internet we have today, application architecture is constantly evolving. And as we move into a new era of artificial intelligence, the Internet of Things, and computing at the very edge of the network, well, the blueprints for our digital world are being redrawn all over again. The real question is, what are they going to look like tomorrow?